In this video, we're going to replace the pressure sensor on a Whirlpool, Maytag, or Amana control board. This fix would be similar for huge numbers of control boards. The replacement was shot specifically for control board failures surrounding machines that are failing to drain properly, shutting off randomly, or the most likely one, the drain pump is running constantly and failing to turn off when needed, or overfilling the tub when set to auto sensing. Generally, this solution is going to be good for control boards that are green and similar in form or fashion to this one. The tools needed for the job are a soldering iron and a way to desolder the pressure sensor. The links to the desoldering pump and soldering iron will be included in the links, but there are many different styles and ways you could do this. Additionally, the video assumes you have a solder wire for the installation of the sensor. We suggest a low temp solder wire with a rosin core. Although not needed, we're using a set of helping hands during the repair, and honestly, this video assumes you have the basics of soldering done. There are many videos that will show you how to solder things better than this video would for a tutorial. The first step is identifying where the pressure sensor is on the board and the 8 pins that go through the PCB holes on the underside of the board. This board is shown with the underside facing the camera. These are the 8 pins that are going to need desoldered. As a note, some of these boards will have a light layer of conformal coating on them. To remove them, you'll need to use a hot air desoldering tool or a solder gun to remove the spot coatings, which is why we opted for a desoldering pump for this repair that has a heating element installed on it. This step will vary based on technique and the tools you have for the fix. Each of the 8 pins need desoldered from the board one by one that hold the sensor in place. The pins are flat and wide, and the ease of removal is going to vary from board to board. This particular one we filmed was more difficult than the last one we did off camera. We now have one side mostly desoldered. Note the bottom pins still need desoldered more fully. They are not uniform, as it looks like this board had been remanufactured already from someone else. We did not touch this board previously to the video. Continue to remove the solder from the remaining pins. This can take some time to work out with your desoldering medium of choice. We ended up having to flip the board over and continue to gently apply pressure to remove the sensor with a pair of needle nose pliers as the desoldering pump works to remove the remaining solder. Again, due to how flat these pins are, it was a little bit tricky removing everything on camera. Be careful to note the pins. We did have 1 or 2 pull away from this old sensor. We used a pair of needle nose pliers to remove the sensor and the pins fully as he worked with the desoldering gun. It took about 2 or 3 minutes worth of desoldering work, and then the sensor was fully removed as you see here. The next step is going to be then to install the new sensor. This one we sourced and we are going to sell it in the US to different customers. Specifically note the part number on the screen. I'm going to have a link to buy them in the description as they are not easy to find online, and the style of pressure sensor could vary from board to board, so make sure to verify this is the style you need, although this is by far the most common. When you install the sensor, it has to be installed exactly to the board. One row of pins does nothing, while the other row supplies voltage as needed from the sensor to the board to operate properly. Here are the views you're going to see from a clean board and installation close up. Hopefully this view makes sense. You can see the traces that will match up with the proper installation of the pressure sensor. The yellow marking on a manufacturer control board is something that Whirlpool does, and when you get these sensors from the Panasonic factory, it won't show this. Pin number 1 is supposed to have a chamfered edge on the top, but it's nearly impossible to see on camera and often in person. So knowing that the pressure hole is in the middle of the opposite side of the pins makes the most sense to explain it in the installation, so that side needs to be away from where the traces are. And once you have it ready, mount the sensor onto the board. You're going to need to hold the sensor in place while soldering. We ended up using electrical tape to hold it in place. If you weren't using helping hands like we are, the sensor could potentially just rest against the table to hold it in place. The next step, once the sensor is in place and properly oriented, is to solder the sensor into the board using your soldering iron and wire. This step was far easier than the extraction. The 3 solder points on the bottom are the key locations. Make sure that the solder doesn't reach the other pins in the process. Additionally, don't heat the sensor up too much during the soldering process. That's why we went with a low temp solder wire. You don't want to damage the contacts inside the sensor. You can use a phone or magnifying glass to zoom into the process to ensure that the solder points aren't touching, which would cause it to ground out and fail to run properly. Although the solder job isn't perfect, soldering really isn't about perfection. As long as the solder attaches from the sensor to the board, you're good. With all of this done and the solder now cooled down, we're going to go ahead and gently plug the 7 wires back into the board and then power the washing machine on to view the process of operation. The unit is still running the flood control operation with the pump on. This was the last command that the board was given before we took the sensor out. We could let the system run for 10 minutes and finish out, or we could just press and hold the red pause/cancel button for 10 seconds and let it cancel out. The repair should then be fully complete, but we have to verify that everything's working first. The 2 ways you could test this would be to use a multimeter and test the voltage going from pin 3 to 4 on this sensor during operation. Proper voltage would be about 0.3 to 0.4 volts during the filling for AutoSense, or you could just run a normal load of clothes in the machine and confirm that the unit fills to an appropriate non-deep fill level. This shows that the sensor is providing feedback to the processor that it's reached a proper fill state and shuts off correctly. If the sensor was bad or something went wrong, it would overfill, which could lead to flooding or other issues, but we have yet to see that ever happen when installing a new sensor. If you're satisfied with the fix, you can use conformal coating to the rear side of the board where you soldered the pins in. A very light coat will ensure that moisture does not damage the board. It isn't required but certainly suggested. There you have it, a working control board without replacing the entire system for hundreds of dollars. The pressure sensor was a fraction of the cost of that board. Again, I'll have a link to all the components and tools we used in the video in the description, the comments, and through YouTube shopping. I hope this video helps you out to have a great day.